and it's our job to guide the acceleration, not to stop it. Each of us personally can grow by the pain we feel or the vision we create. The first path is the most common for human beings, but it's also the most wasteful and violent and traumatic. The second path is rarer, but it is the path that we must strive for as we learn to take responsibility for our own lives. The model of change that I wish to propose in this talk is called Evolutionary Development, or Evo Devil. It is a model that a few thousand biologists and other scientists find more useful than simple evolution or Darwinism to describe both biological and non-biological change. Evolutionary processes look like growing trees, with more branching on the tree over time, and each branch is unpredictable in its direction of growth. Think of Darwin's tree of life. Developmental processes, by contrast, look like funnels, the opposite of a tree. They take the chaos and diversity out of a system, and they guide it to a highly probable and predictable future. Development is also a cyclical process. Think of the life cycle between a seed, the organism, and the new seed. Perhaps the best way to understand the Evo Devil model is to look at identical twins. Everything about them is built at the molecular scale, bottom up, in a chaotic, creative, and selectionist fashion. This is an evolutionary process. It is deterministic, but also chaotic. It continually branches to create new combinations in unpredictable ways. This is why genetically identical twins have different fingerprints, different retinal prints, different brain wiring, different organ microstructure, different beliefs, different behaviors. Everything about them at the molecular scale is built in a tree-like way. Now look at these same twins from across the room, and you will see that they are very similar. They grow at the same rates, go through life stages at similar times, and if they are separated at birth, they are 65% correlated in major psychological variables. All of these are developmental processes. The funnel of development is guiding these organisms to many of the same future forms and functions on a global scale. That this funneling can happen at all is one of the greatest mysteries and miracles of life. Now imagine that the universe is a little like an organism, and that it too has tree-like and funnel-like processes. It too evolves and develops. If this is true, when we find other Earth-like planets, we will discover both evolutionary differences and developmental similarities. This is a representation of the Evo Devil model. We are coloring evolution in green and development in blue. Note that Darwin's tree of life, natural selection, is also called Evo Devil, a combination of evolution and development, a mix of green and blue. Below the level of the tree, there is a third actor, chaos, as represented by the purple Lorentz attractor here, which drives much of the creative and experimental processes of evolution, as we are defining it. This slide shows a simplification of the previous slide. Every complex system, whether physical, chemical, biological, social, or technological, shows both evolutionary creativity and developmental convergence, sustainability, and life cycle. The tree of the funnel of development in life and other systems protects the system from the evolutionary chaos of the world. The tree of life in the middle represents both the diversity and the intelligence of our planet. Each branch of the tree is adapting and learning as best it can. Each branch is computing in its own way. Combining these three processes, reading left to right, we can call this an Evo-Compu-Devo model. Different mathematical curves are associated with each of these processes. Evolutionary processes fill their niches with power law distributions, with fat heads and long tails. Think of the Zipf or Pareto distributions. Developmental processes often produce normal or log normal curves. Think of the distribution of IQ, height, blood pressure, or other developmental variables in a population. In the middle, we have adaptational and learning curves. The logistic or S curve is one famous example represented here, but the exponential growth is another learning curve. We can also speculate on how human society uses these three processes. Consider how we are always creating and innovating as an evolutionist, and we are always trying to predict, discover, and sustain as a developmentalist. In the middle, we have Evo Devil, the managers and politicians who try to guide the world toward an agenda to measure their progress and benefit from their plans. So we have the artists and the entrepreneurs on one side. We have the scientists and the sustainers, the environmentalists on the developmental side. And in the middle, the managers and politicians. This model is not mine, but the work of Jacob Bronowski, the Polish mathematician and biologist. St. Francis of Assisi said we should ask our God or the universe for the courage to change the things that we can, the serenity to accept the things that we cannot change, and the wisdom to know the difference. I believe it is this wisdom, this vision to know what evolutionary things we can and should change, what developmental things we cannot, that we must continually strive for. We will not stop accelerating change. We must instead learn to ride and guide it well. One of the surprising Evo Devil discoveries is that the vast majority of events in our universe appear to be evolutionary, as far as we can tell. Only a very small set, 5% or less, are top-down, hierarchical, or funnel-like processes. A good example can be found in the genes of every living organism. Almost all of the genes can change often to create different evolutionary phenotypic variety. But about 3 to 5% of the genes, the developmental genes, change very little. These are the funneling genes. They take the molecular chaos and environmental chaos out of a developing organism and guide it through its hierarchical development or life cycle with high probability in the right environment. Because evolutionary processes represent so much of a system, developmental processes are easy to miss, and they are much harder for scientists to understand. So we are late to seeing development in the universe. Many physical systems, nevertheless, seem to have been created by this combination of chaotic experimentation, tree-like selection, and developmental-like funneling and convergence and unification. Even the universe, according to the cosmologist Lee Smolin, is both evolving and developing. It was born in the Big Bang like a seed, has unfolded into an organism, or something like an organism, and a few of its processes have emerged in identical developmental ways isotropically throughout the universe. I'm a member of a small international community of scholars who investigates evolutionary and developmental process at the universe level and subsystems. And if you'd like to know more or participate, please visit us at evodeviluniverse.com. In case you're not yet convinced of this view, here are a few more examples of proposed evolutionary convergence or developmental archetype. The books on this slide provide many more examples. From carbon chemistry to RNA, to eyes, to bilateral symmetry, to prehensile limbs, to opposable thumbs, to the tetrapod, to the anthropoid form, to rocks and clubs, which we use to stop leopards from coming toward us, making us now the most dominant species on the plains. Throwing them with our opposable thumbs at 90 miles an hour, not just one of us, but 20 of us at the same time. Now we don't need to be thicker skinned or faster. We just sit around the fire and start synchronizing our squeaks and figuring out how to use our brains to create things like spears and levers and ropes and wheels and pulleys. And then chemistry, math, science, computers, becoming AI, all of these can be argued as highly developmentally probable convergences on the leading edge of accelerating change on Earth-like planets. This is not a popular way of viewing history, as it seems a return to the ladder of life metaphor, which placed biological humans at the center of creation. But it is no return to the ancient ladder. In this model, biological humans are stewards of complexity for a brief time, before they must permanently pass the baton to their post-biological children. Now we are ready to consider the question of accelerating change. What drives it and where is it going? As I will suggest, it appears to be leading us on a race to inner space. Not a journey to the stars, but a journey inward, to mental and virtual realms beyond our own, and to physical realms that are far smaller, faster, and smarter than those we inhabit today. Recall, if you will, the cosmic calendar diagram of the astronomer Carl Sagan, described in the book The Dragons of Eden. This is one of the classical images of big history, the timeline of universal complexity emergence. Note that it accelerates greatly in the last few billion years. What is harder to see on this diagram is that complexity emergence is decelerating for the first few months of the universe's life, as it expands and cools. This diagram makes clear this U-shaped curve of universal change with time. At first, we see very rapid change with time as the seed of the universe is unfolding. Then rapid change again on all the special Earth-like planets, of which there may be very many in our galaxy. Now, if our universe is developing, we should look to biological development to see if there is a similar U-shaped curve. In fact, there is. The Russian biophysicist Alexander Zotin first mapped this curve. He showed that growing organisms first decelerate in their energetic flow per mass and time as the seed is unfolding, and then as they get ready to give birth, greatly accelerate their energy flows again. This is the red box in the diagram above. Considering this, perhaps one of the purposes of accelerating change, part of the reason for humanity's journey, is to develop in such a way that we can successfully give birth to a new universe or new civilization or new something. If we have been good parents, it will exceed us in its finer qualities the way our own children exceed us if we have raised them well. I find this a fascinating idea, and the Buddhists, among our other spiritual leaders, may find some resonance with this idea as well. Now, perhaps the best example of a predictable funnel-like process of accelerating universal change has been given by one of our speakers, Dr. Eric Chason, in his curve of energy flow density in complex systems. The closer we get to the present time, the greater the energy flow density at the leading edge of complexity, as he defines it. At the top of this developmental hierarchy of energy flow is not humanity, but our computer chips, which are processing, working, and occasionally learning at rates as much as 10 million-fold faster than human brains. Note also that the higher the energy flow density of the system, the closer the system approximates to a black hole, which may be where Earth's intelligence eventually goes, as I have written in my article, The Transcension Hypothesis. Black holes are the ultimate form of inner space, places that are separate from our universe in important ways. For our last slide, we can now consider two of the ways that we are racing to inner space, ways that we are just beginning to realize today. One way we race is by growing our information technology, or our simulation ability. Recall that children spend hours in new forms of play every day, trying new things in physical space. But as adults, a recent Harvard study said we spend less than 15 minutes doing something new or creative in the physical world every day. Instead, we adults simulate in our minds, based on all of the previous memories we have stored from physical play in the past. And this move from physical to virtual space to the mental world in the adult mind allows us to do many, many more evolutionary searches and creative experiments than we could do by spending our time in slow and expensive physical space. Our computers, for their part, are doing exactly the same thing. They are growing their simulation and imagination ability far faster than human brains, though they are much simpler than us still today. The second way we go to inner space is by nanotechnology, the creation of ever smaller thinking and productive systems. As long as intelligence can move its complexity to smaller, faster, and denser domains of reality, we will continually discover a paradise of resources in inner space. We will not run into resource limits because we go below the level of resources at every new emergence, and the acceleration continues. This observation helps us see that preparing ourselves and our children to understand, critique, and use computers and technology has become one of the most important priorities for us as citizens, as planetary citizens, as digital citizens, because the race to inner space will only continue to gain speed throughout the rest of our lives. One day, in fact, if you listen to the transhumanists, as I do, our biology will very likely migrate all of its intricate patterns to the much faster and smaller and resilient electronic world. The future of humanity does not appear to be in the stars, but inward, toward the smallest scales, toward black hole-like domains. Our destiny is density. This Congress has provided many ideas for how humanity can rise to the challenge of accelerating change. I, for one, hope that we can continue to find the courage, serenity, and wisdom to navigate the future, and that we do so with as much vision and as little violence as possible. Thank you.
Thank you. I'm afraid no time at all, but later on discussion, because we are really in a hurry now.
Thank you.
Коллеги, если есть вопросы ко всем спикерам, да, завтра круглый стол или после окончания пленарного заседания, просто мы затягиваем время, а все кончается, не только наши жизни, но и аренда зала, и мы должны успеть сделать все самые главные дела до того, как и то, и другое закончится. Barry Roderick.